start the record. Okay, the audio is on recording, so I'm going to share now. All right. So we are here in account management. So if you notice, you have an assignment, right? And you have a document that you need to work through. I have a couple of slides here, a couple of documents. I'm going to download them. Okay. So we'll go through these. Okay, and so this is the slides that I have for this. So always make sure, as a reminder, that there are some managerial topics, right, related to the class that you should just be reading. Instead of reading the book, I've summarized all of that into these slides, basically. So there's one here on documentation. When you're a sysadmin, why document? And so just basically make sure you go through this. It kind of covers a lot of things that you probably already know about, but there are tools that you can use to store data. It also talks about Linux, the man pages, and how you can get information about Linux itself through the man command. Okay, and so it'll give you information. So make sure definitely just to read through this or read the corresponding chapter. All right, so if you remember, account management is this topic actually. Okay, so I was saying, we looked at the topic of account management on Thursday, but really the broader term, the more generic name is namespaces. Okay, so namespaces is really the encompassing thing, that the broader area that includes account management as a sub area. Okay. So this is the terminology that you'll see in the book. So basically, namespaces in your operation just represent a set of unique keys and associated attributes. So examples of these are going to be account names, right? So that's why we focus just on this topic on Thursday, but actually there are other things that could be namespaces in your environment, right? So you have account names, printers, the names of the host machines, the servers themselves, Ethernet addresses, basically a service, port number list, etc. So any collection of things, right? A namespace is just a set, a list of unique keys and associated attributes. So anything that you can group into a list in your own environment. Okay, so that's basically the definition. The namespace, the term namespace can be confusing because it can refer to either an abstract concept or a concrete thing. Okay, and that's really all I want to say. Really, I'm not going to get into all the little details about this, but you get the idea, right? So all these computers, they're a namespace, right? And all of you, right, your accounts are a namespace, right? That has to be in some way control, that you need to monitor and provide permissions for, etc. Okay. So basically every namespace has attributes for each element. So here, for instance, for account names, as you know, you have UIDs, right? You have home directories, etc. For host names, computers, they'll have IP addresses, serial numbers, MAC addresses, etc. Right? So everything will have associated fields with it. Okay, and namespaces are the lists and dictionaries in your environment. So files in the file system, account names in use, printers available, names of hosts, and so on. Okay, so hopefully that clarifies what namespaces are. So namespaces will need to have policies, procedures, and centralized management. Right. So what that means is, how do you deal with a namespace? How do you deal with adding new elements into the namespace? So how do you deal with adding new accounts? How do you deal with adding new servers, etc.? Okay, so that's kind of the idea. So you need to come up with these and establish these policies that will govern the use of your devices. Okay. All right, so that's basically the idea. And then now you can read through the rest of the slides just to understand a little bit more, get a few more examples of namespaces. Okay. We will basically just focus a little bit on the accounts, given that that was the topic of the lab. So, the account management, basically, as you know, in Linux, so you have, or Unix, I should say, you have the passwd file and the shadow file, right? So you have these two files. The passwd file just contains the user information, but the password is usually separated out into another file. You can see here, so these are the account files where you have information, the shadow. Oh, I'm sorry, guys. Yes, you were supposed to. I apologize to you guys in cyberspace. Do you see the slides now? Yeah, sorry about that. All right. Anyway, you can read through the slides. Not much, so just read through them. What was I saying? So we have the account, right, in Linux or Unix. And this includes the account components, so the username, the UID, the password, the home directory, right? We have a few files, passwd, shadow, and group. And then as far as account management, this is what you were practicing on Thursday, where you were adding users, you were practicing removing and disabling users, and all those tasks, right? So this is what we were doing on Thursday in the lab. So in the past, so we have two files in Unix, the etc passwd file and the etc shadow file. So the etc passwd file contains the username, UID, default group ID, geckos, which is something that is kind of taken out now, home directory, and the login shell, right? And these are the main components that are still there. The login shell is what you use to bin bash. Home directory is where your files are stored, and then your UID, your group ID, and your username. So you can see an example of that here, where we have user student. The X here just indicates that this user has a password in the shadow file, right? An encrypted password. User and group IDs, right? And then some information, the gecko, some like administrative things. And then this is your home folder. You notice, so you're in home, and then you're student, so your folder is called student. And then finally, this is your shell, which allows you, your login shell. When you log in, you're associated with this so that you can basically type commands, etc. Okay, if you notice in the passwd file, the files are separated by colon, right? So colon. The shadow file will contain, as you can see here, the username, and then the encrypted password. So you can see that there. This is the encrypted password. And then some information related to days of last password change, days till change allowed, days till change required, and some expiration parameters, okay? So this is the information that's contained in both of those files. All right, as far as syntax, that that changes from operating system to operating system, but what's important is you can create accounts, and those accounts are associated with the UID, which can be a 32-bit non-negative integer. And then just remember or be aware that the ID for root is 0. So the 0 value. As you know, passwords are hashed with hashing functions such as MD5, SHA-1, SHA-256, and so on. So those are all the hashing algorithms in cryptography that allow you to encrypt a password. The group ID is a 32-bit non-negative integer. Each user has a default group. Groups are described in the etc group folder, and users may belong to multiple groups. And then this is an example. So you have a group wheel, and then you have individual users that belong to that group. Okay. And then, as I said, this is just information that used to be there, but if you look now, there's usually nothing there. Okay, and then the rest of this is just the commands that we went over in the lab. So I'm not going to repeat this, but these are some of the things, some of the tasks that were presented in that document. Okay, and then the permission. So that's basically just going over these slides, a few additional things that I haven't covered before to kind of wrap up user account management. Okay, so let's go back then to Brightspace and just take a look. So let's. Now you guys started working on the lab assignment on Thursday. Are there any questions about that lab assignment? Yeah, go ahead. Yeah, go ahead. Mm-hmm. Yeah, you have to, so the script has to invoke a command like user add or add user, and you have to provide enough parameters in there so that the users can log in. What you could do is just, sometimes you can set so that the user, when they first go in, they have to change their password. Yeah, but you can't manually. Yeah, the script needs to create the 30 accounts and then just test that at least you can log into one. Got it? Okay. All right, so that's the commands. I'm not hearing any other questions on labs. All right, so that's, besides the lab and just going over these slides, kind of that's user account management, okay? Unless there are any questions, we're going to move on to the next topic, which is, kind of the topic for the week, which is DNS, okay? So you will have a lab assignment, and this lab is actually a 2-week lab, so you won't be able to solve it, or we won't be able to complete the topic in one in one lecture. So let me make sure I'm in 1 week. I'm not sharing again. All right, so now I'm sharing. So as I was saying, we are done with account management. Just make sure you complete the lab assignment, which is due this week, right? So just make sure you complete that. And then now we're going to start the topic of DNS, okay? So for this one, it's actually kind of interesting what we're going to do. So let me go to the whiteboard. Let's think about the DNS. So today I'll go over a little bit of the lecture on DNS and kind of how that works. But also, I want to talk a little bit about the lab before I start with the lecture, because the lab is interesting. So what is DNS, right? So DNS server, a Linux server that is going to, whenever you're sending, you want to reach something by IP, it needs to give, sorry, by host name, it needs to give you the corresponding IP, right? So you can imagine you have a computer here, and the computer is trying to reach some other computer, maybe out in the internet somewhere, right? And you're going to send a packet, and the packet is going to say, I want to go to www something. So you need to resolve via the DNS the corresponding IP address for it. You guys see that? So that's the general idea. So we're going to create, in this lab, you're going to need, if you remember, I think I said last week that you need to have 2 VMs, okay? So at least, in reality, you should probably have 3 VMs, okay? So one is a DNS server, one is a DNS client. So the very first thing you're going to do is you're going to configure one box to be a DNS server. And to do that, you're going to set up something called bind. I'll talk about that today, bind 9, which is basically a service, right? Bind 9 is a DNS service in Linux. So it's a DNS service in Linux. So you're going to configure the server, first of all, to be a DNS server, which means that it has to respond to requests, etc. And then also you have to configure this one as a DNS client, which basically means that you're going to tell this DNS client to communicate with DNS server whenever it needs name resolution. Does that make sense, guys? So for this week, all you have to do is that. Your focus needs to be on setting up bind 9 in the lab, right? And then testing this functionality that it does work, that DNS client uses DNS server to resolve things. Yeah. Nope. It's just Linux. That's the beauty of Linux. That's actually what I want you guys to get out of this class, is that every service you can install on just any plain Linux. You don't need to get a like in Windows side, right? You have to get Windows Server, and then it's got to be this and that. Now there is Linux Server, right? So there are Linux servers. They're just the firmware is more optimized, but at the end of the day, it's kind of the same. You see that? So that's the point. And so you can just start with the Linux VM that we're gonna set up that you have, but you're gonna install bind 9. All right, and this is in the documentation, so I'll talk about that. And then, as I said, you'll do some configuration on the client side. And then, first of all, this client now will only be able to reach the outside via that DNS server that you configured. Okay, so that should be the first part. Let's call it part 1. Okay, just configuring that. And then part 2, and I'm not going to break this up probably into like 2 homework assignments. It'll just be 1 homework assignment that that goes for 2 weeks basically. But then part 2 will be very interesting, because we're going to launch, or we're going to try about 3 different types of attacks on DNS. And really, the point is not so much to learn how to do the attacks on DNS, but by doing these attacks, we will understand a little bit more about how DNS works itself. Do you guys see that? So that's really the point. Remember, this is a sysadmin class, so the point is really to understand how it works more so than the attacks themselves. Okay. So, but we will be, and it's very simple, basic attacks, but they're nice. One of the things here that I recommend you use is Wireshark, right? Have that running in the background. You know how to use it now. And so that way, whenever you launch an attack, what's going to happen is packets get sent, right? And you should monitor them. You guys see that? All right, so then that's part 2, running the attacks. So then the scenario, if we want to think about it, we're going to do like, we have a network, right? We have a network. We have a DNS server. We have a DNS client. And so the DNS client wants to go somewhere. So they're going to send a packet here, right? You know, some little packet. But in part 2, and this is bind 9. But in part 2, there's also going to be another machine called the attacker. And all of these can just be your CD Ubuntu VM because they have all the software that you need, so you shouldn't have any problems. So what's going to happen is, for instance, one of the attacks could be that the attacker takes out bind, right, with a denial of service attack, and then pretends to be a DNS server. So it's going to sniff this packet. It's going to understand what it wants, and then it's going to do what it's called spoofing the response, which basically means that it's going to pretend that it was the DNS server and then try to trick it. Do you guys see that? Does that make sense? And I'll elaborate a lot more, obviously, on these, but I'm just trying to give you the basic scenario. And so we're going to do 3 attacks like this. One is they're very straightforward, but usually I don't start with this lab, right? You know, it's almost the middle of the semester at this point. So I expect you guys have at this point developed a certain level of confidence with Linux, because this one is a little bit more challenging, definitely more than before. Okay, so but by no means is this the project at the end of the semester where I ask you to configure something like Hadoop and Linux. That's much more difficult. What's what? A what? Oh. What? What did you say? I'm sorry. What's the word? What word did you think I said? Which word did you think I said? Hadoop? Dukin. Okay. No, I said Hadoop. Yes. No, that's okay. Sorry, I didn't understand your reference. So you were talking about Dragon Ball, I think. Yeah, I go as far as that. I understand that. All right. So anyway, but my point was, you know, in the semester we started, you know, hopefully you may have started at 0 with Linux. We're kind of in the middle of the semester. Now you have a much more challenging thing, configuring bind. So you have to do that carefully. You have to really concentrate when you're doing this, okay? That's what's one thing with Linux. And then at the end of the semester, as I said, you're going to have to configure Hadoop. This is worth 5% of the total grade. It's just, you know, project. I think I call it project A or something. This one is much more challenging to set up, but bind is certainly a good practice to get you to that. You see that? So it's like a much easier one to configure. You know, a lot easier. Does this make sense, guys? All right, so that's why I want to stress. So this lab topic, DNS, it's a fun one for sure. But be aware, it's not just about the topic DNS. I'm actually hoping that you're building up your skill. Okay, so you know, this one's not as hard as the next one. Be aware when you're doing this, do everything right so that you're practicing for the next one. Okay, all right, so that's the idea with the lab. So we will talk about that. So we can go then to the document. So let me go back to Brightspace and just get a feel for what's in here. So if we open this file, you can see this is the homework document. So complete the attached DNS lab, complete the following. Part 1, configure the DNS server with bind and the DNS client, which is what I described. And then in part 2, complete the problems as described during the lecture, which are problems 1, 2, and 3. So you will modify the etc host file, and you'll have to think if you do that on the client or the server. Problem 2, you're going to disable the DNS server. and have the attacker respond to clients' DNS queries. And then finally, you're going to do in problem 3 what is called a DNS cache poisoning attack, where you're actually going to attack the DNS server and try to change something in it so that when other people contact it, they're getting the wrong information. Okay? Yeah. So that's the idea. This is the homework, okay, that you can work on Thursday. And then here I have a PDF. Okay, there's the PDF, and then also let me open the slides. Okay, and you can see this is what I'm going to go over in class today. So just this information, you have all of it already in here, right? So you can just reference it from there. But I'll go over this today. And then you have the PDF itself, which I think is this one. This is the assignment, basically, the assignment document, okay? So you will, it's called the Local DNS Attack Lab from the Seed Labs. And you can see it's got all the details of what the lab entails. So I'll start with the lab, actually, just to kind of get you understanding what it is that you need to do. And then we'll get towards the end of the class, then we'll just talk about the lecture, kind of the lecture topics. So let's see. And you only have to do, you don't have to complete the entire lab, but let's start here with the lab overview. So lab overview, so the DNS domain name system is the internet's phone book, basically. It translates host names to IP addresses and vice versa. This translation is through DNS resolution, which happens behind the scenes. DNS attacks manipulate this resolution process in various ways, right? Because everything is being sent via packets. So the point is to intercept those packets or drop them and then send your own spoof packets. DNS attacks manipulate this resolution process in various ways with an intent to misdirect users to alternative destinations, which are often malicious. The objective of this lab is to understand how such attacks work. So students will first set up and configure DNS. So remember, that's part 1. You know, on your VM, you'll have to set up the DNS server, and then they will try various DNS attacks on the target that is within the lab environment. And you should use, as I said, Wireshark to capture the packets. The goal is really to understand the communication. The difficulties of attacking local victims versus remote. We're not going to do remote DNS attacks. You should not ever, right, do that at all. Just, you know, be aware of that. Everything should be in your controlled environment. So we're going to use a tool that would allow you to do those things. So you should not, as I said, do that. And everything should just be in your 2 VMs. Therefore, we have, so there's 2 labs, but we're only going to focus on the local DNS attacks and not remote DNS. So this lab focuses on local, and basically the lab covers DNS and how it works. So I'll do this in the lecture today, and then DNS server setup. So the instructions should be here, so I'll show you. And then after that, there's going to be the DNS cache poisoning attack over here. DNS cache poisoning and also spoofing DNS responses. I'm not sure that I'm going to get into SCAPI. This is something that I cover in another class. So we may just use a tool called NetWalks for this and not get into, because SCAPI is coding. So we'd have to get into a whole bunch of things. So we'll probably not skip this, but if you want to learn about SCAPI, when you take other courses, you will see that. All right, so the first part is, let's take a look at part one, which is basically setting up the local DNS server. So the main purpose of the lab here is, to set up and also to do the attacks. And this just gives you the disclaimer that it's illegal to attack real machines. So we're going to conduct this on our own DNS server. You're going to set it up using something called bind9. Here's some I recommend actually read this whole document. Okay, read the whole document in detail because it has some specific things on VirtualBox or VMware depending on what you're using. So definitely take a look at that. Here is the environment, as I said, basically 3 machines. You have a local DNS server, you have the DNS client, and then you would have the attacker, right? All in the same network. So ideally, this is the way that you should make it work. Some students in the past have just launched the attacks from the same client machine. In theory, that works, right? Because at the end of the day, you're just sending out packets, but just be aware of where you are. But definitely, you need to have one machine that's configured as a DNS server, one that's configured as a DNS client. To configure the machine, you're going to have to follow these instructions. So I'm not going to read through this. This is to configure, just notice, this is the instructions to configure the user machine, okay, the client. So make sure you read through all of this. Okay, it's got all the information. Then you have the instructions to configure the DNS server itself. So that's the other machine. Remember here, this I'll say all of this in the lecture. I have a more summarized version of it, but this is basically the program bind9. Okay, and that you'll be able to install that. And then after you install it, you still need to update some files. Remember that the Unix way basically says that everything in Linux is a file, right? So remember that. And so because we say that everything in Linux is a file, even configuration is just done on the terminal, really on simple files, right? It's a convenient way. So you will have to, and this is where actually, like from this step on, this is where you have to really focus, okay, on the steps that you're doing. Read it carefully, okay? Don't just like type it like that, because one little typo will ruin everything. And if you don't, if it doesn't work, and it happens a lot of the time, it doesn't work, students just have to start all over, right? Until they find the error. So pay attention to all of this. I'll go over some of this in the lecture. Once you've installed it to start DNS server, remember the sudo service command. You can start bind9, restart it, and then basically test it and use it. Okay, then this information about the zones, you'll have to also read about that, okay, and follow the directions. Now, you'll have to create some files with this content. My suggestion is don't type this. If you type this, this has very like invisible characters in it that you're not seeing. So the best thing is just go to the seed labs under this lab and download this file, okay? So I recommend that strongly. Otherwise, guarantee that it won't work if you just type it up. And this is the same. So I'll talk about these two files also a little bit later. So there's a lot of information. Okay. All right. And then once you've configured the zones, which I'll talk about, then that is basically the amount of work that you should do this week. Okay. So really for this week, you should get until about here and make sure that the DNS client is using the DNS server. You guys see that? Does that make sense? All right, great. Now for next week, and next week I will talk about the attacks during, okay. And then next week during the lecture, I will start here and I'll start getting into the attacks themselves, okay? And kind of going over the scenarios. So I'm not going to address that part today. All right, so that's basically the document. So now, as I said, I'm just going to go into the details of the lecture, but I just wanted to start here to kind of motivate what it is that you need to do. So is this description clear? Do you guys understand? Yeah? All right. Pretty much, exactly. Setting up the network, setting up a DNS server, just making sure it works. And then with the attacks, you're really kind of understanding how everything works deep down. Okay. All right, so we're going to go ahead then and now switch over to the whiteboard. And as I said, remember, all of this is already written up in the other slide. Okay, so we're talking about DNS, right? So that's the main topic, DNS. And as we said, we are basically mapping from host name to IP address. Okay, that's the basic idea with DNS. Okay, at the most basic level, network operations depend really on just two. So DNS depends on two abilities. Okay, so that's basically it. So it's got two things. The first one is, of course, it needs to translate host name to IP. So translate host name to IP. All right, that's the first one. Let's say number one. And then number two, it needs to determine the route to a remote destination. So determine the route to follow. Okay, so these are DNS basically is in charge of these two ideas, just translating host name to IP and then determining the route to a desired destination. So this is why to accomplish this task, DNS has been created. So DNS stands for the domain name system. Okay, and it is the facility that provides name resolution. Okay, name resolution service. So now think about this. DNS is only a specification. So DNS is a specification. So what that means is that it's just, you can think of it as just like a description of how it should work. Okay, so it's the specification. In Unix, the implementation of DNS, so in Unix, the actual implementation is called bind. Okay, and bind stands for the Berkeley Internet Name Domain. Okay, so bind is the Berkeley, well, probably because it was developed at Berkeley, back in some time ago. Now, because the DNS system is a distributed system, bind has to do two things. It has data called zones. So it's got zones, which is the data, the mapping data, let's call it. Okay, so, people create their own DNS servers for their own business, their own university. Within that DNS server, they have to create these zones where they specify these are the names, these are the IP addresses, right? And I'm the authority on this DNS information. Okay, but then that information needs to be distributed across the internet, right? And so what happens is, the bind system. So the bind system consists of two activities. Activity number one is, so the activities of bind, let's say, of bind are the actual translation, from host to IP, right? That's one. And then the other thing is the distribution of the translation data. And that doesn't mean that they have to send the information to a central location. So the information is not stored centrally, but there has to be some communication about who is the authority for what. Okay, so that's really what that implies, that the distribution of translation data implies, okay, if this DNS server does not know this, who do I contact to get more information? So we're all familiar with something like Google, right? 8.8.8, where they're kind of an authority that if you don't know something, you send them a query, right? And then they'll probably know because they're a very centralized DNS that collects a lot of information about who is the authority for what. Okay, but this is the idea. So the DNS server consists of two distinct activities: the actual host name to IP address process, which is the translation process, and then the distribution mechanisms for the underlying translation data. So structurally, DNS is a distributed database. So structurally, DNS is a distributed database. Okay, whose contents are spread across the internet, basically, with individual DNS servers permanently storing only the subset of data for which they are responsible. And this is what I was saying, right? So every company, they have, this is company A, company B, and then they have their own DNS server. And then in that server, they have the information that pertains to them, right? For their publicly facing, obviously, devices, right? So their email servers and their web servers, et cetera, and whatever other servers that they might have available. Okay, so that's the process. Now, how do you query this this distributed database, right? So it's a distributed database. So then how do you query it? Okay, so queries into this massively distributed database work because DNS has the ability to forward translation requests to the appropriate server automatically. All right, so and that's one of the things that you will actually look at the lab, right? So if you don't know who is this, then you're going to go to a DNS server. If that DNS server does not know, then what are they going to do? They're going to forward that packet to some other authority. Who is this? Until they finally, eventually, when they find a response, they're going to keep it in their cache. And so hopefully they don't have to query again. Does that make sense? So that's the idea. So queries into this massively distributed database work basically because DNS has the ability to forward translation requests to appropriate servers automatically. So queries work basically because they can be forwarded. So they can be forwarded to some other DNS server. Okay, but you have to configure then, if you have a DNS server, what other ones you can look at. The DNS organizational structure defines the domain name hierarchy familiar to most internet users. So domain names are managed within a tree structure rooted at the root domain. Okay, underneath the root domain are the individual extensions that we have. The .coms and all those suffixes, right? So we have, for instance, the root. We have the root, right? And then we have the organization types. So we have .biz, .com, .edu, And then we also have for the country codes. So this is basically the domain names. Okay, so domain names that you have like yeah, go ahead. Yeah. Yes. Yep. I think it's this. It's one central authority, and actually, for instance, .co. I think that's actually the country code for Colombia, but a lot of companies nowadays, instead of getting .com, get .co. So it's really, this is something that has evolved actually to the point where this was an initial classification, but it's now more gray. And so people can just use, kind of what they want. If you think about companies like GoDaddy, their business, their main business is selling these domains. So they're the ones that are probably pushing and going out to this central tree structure and just saying, okay, we need more, .coms are too expensive and people don't want to get them. So we need more options. And so they're grabbing these. But all of these, I don't think they're separate. They're all controlled very, very well, because at the end of the day, it all falls into DNS, right? So DNS, if you think about it, when you do www dot, PNW, pnw.edu, this is all DNS and it's very relevant. The root is actually like here. And then edu is this initial starting point, right? And then there's the company domain. And then this is just a server within that company. So the web server. You guys see that? If it was the DNS server, this would say DNS or DS. If this was the mail server, it might say ml.pnw.edu. You see that? So this is all very relevant in how domains are organized, right? So that's why this said, domain names are arranged within a tree structure rooted at the root domain. And then that's this one here. It just means that's the root. There's basically nothing when, after you type .edu, you don't type anything else. Underneath the root domain are a series of top level domains, whose names, are these ones here basically. So there can be the generic suffixes, which indicate organization type like .biz, .com, .edu, .info, etc., and the ones you mentioned probably. And then there's also usually the country codes like UK and JP and so on. But nowadays, a lot of these are becoming more available. But what's important here is when you define your DNS name, right, is to understand that from root to organization to your own company to the servers within your organization. And this is actually very important because when we do the zones, you will then create all of these. You will have a central zone like pnw.edu, and then you'll have a list of the individual servers, www, mail, DNS, etc. And then you need to map those to the corresponding IP addresses. Does this make sense? Any other questions? All right, so yeah, good question, man. All right, so now so that was just a brief overview or a very high level of DNS. Now let's talk a little bit about the implementation of DNS. Okay, and the implementation of DNS for Linux, as we said, is bind. Bind. Okay, so DNS implementations, including bind, have basically components, right? So they'll have different things that they have to do. The main thing that they do is the name server. Okay, so this is on Unix, this is the daemon name. Okay, so whenever you start DNS, the daemon, which is basically, we define daemon as a process or code that's running in the background. It's usually associated with port numbers, right? And that's DNS. And that's usually when you look at it in Linux, it's called named like that, or name D, right? So name plus the D, right? So that's usually the way that you have daemons in the operating system. Okay. And as I described, to configure bind, you have to first install it and then actually look at all the configure the files in it. Okay. Now, the next thing that we're going to talk about is zones. Okay, so you saw that also in the PDF document, that zones are something that actually is really relevant because you will have to configure it. So let's just provide the definition. So for zones, so the name server provides name resolution services, actually, name resolution services in the form of DNS zones. DNS zone. Okay, so these are text files where you will have the mappings of IPs to host names, basically. And then you have to follow a specific formatting to configure them. So a zone is the name given to the collection of hosts within a domain, excluding any subdomains. Okay, so that's really an important definition. So a zone is the name given and here to the collection of hosts within a domain. Okay, so again, this would be then if we have a zone file, let's say your .edu, right? That's your first descriptor. Then after that, PNW. Say PNW, and then within this, you will have the individual ones like WW, DNS, let's say, mail, and so on, right? So you have multiple ones here, but those are the things that you're going to describe in zone files. So you're actually end up having or you're required to have 2 zone files. So you need 2 zone files. So one is going to be from host to IP, and then the other one is going to be from IP to host. Okay, so that's basically all it is, and you have to configure this specifically. All right, so some zone files will hold records that map host names to IP address, and then the other ones will be the reverse of that. So they're called the reverse lookup zone. So if this is the, let's call it the zone, then this is the reverse lookup zone. Okay, so that would be the name for it. So they basically perform the opposite query. All right, so let's talk a little bit about the history of bind. So bind started in 1984. Okay, and it was developed basically at birth. So not so long ago, right? 1984, think about it. 494, 2004, 2014. Less than 40 years, right? You might think that's a long time, but not that long. And it's incredible that things that we take for granted today, they just, they were an idea in 1984. If you think Facebook started in 2004, and now it feels like, no, I'm just saying, think about me then. But just think about the idea, right? That these things that they seem like such a part of our lives, right? They just started. And for you guys, it'll be soon, probably. It'll be like, oh, Zoom was a thing in 2020, and you didn't even know it existed in 2019. And it's just like that. Anyway, but yeah, so it's interesting that, hasn't been around for that long. So now let's get a little bit more into, so that was hopefully good enough as far as DNS concepts. Let's get a little bit into just Linux places and locations. So in Unix, the master configuration file is called name.conf. Okay, so things that you will need. So in Unix or Linux, let's say, some of the relevant files are, so the master configuration file is called named.configuration. It should be located on the etc folder. So etc named.configuration. Okay, so that's the file. Let's look a little bit at a little bit at the syntax of configuring files for DNS. So this is specific to DNS, right? The syntax for adding to the file should be something like this. So you'll see in the files that you have something like a keyword, and then the keyword will have arguments, and then you have an open curly bracket, and then you have a closed curly bracket and semicolon, and then inside you'll see items, and that terminate in a semicolon. Okay, so this will be pretty much, as you go through the files, the specific syntax that you will see. So for instance, one of the examples will look like this. So let's say you have a parameter called options in there with no arguments. You have an open curly bracket, closed curly bracket, and then in there you'll have a directory, which is var named, right? Just to indicate the directory where something is stored, and inside you have a specific file that you're going to create, something named .cache, or the cache file. Okay, so anyway, so this is the basic syntax of this. Okay. So what are other places? So what's another place where you can configure, let me ask this question in a different way. So we know that we have a DNS client, and the DNS client needs to do name resolution, right? So basically we've been saying that you contact a DNS server. But in Linux, what if you don't have a DNS server, or you don't want to use a DNS server? Is there another alternative that you could use? Instead of having a DNS server, is there another alternative you could use to do name resolution in Linux? Can you guys think of something? Is there a file in Linux where you can maybe do some kind of attempt to do some name that you can use to do name resolution? Is there a file maybe? Okay, somebody in the virtual space. Host file, yeah. Are you asking or answering? Are you saying that? Yeah, that's your, yeah, the host file, right? So there is in fact in Linux, that's a good answer. So in Linux, there in the etc folder, there is a file called hosts. Be aware of that. This is important, right? So all Linux machines have this file. And in this file, you can actually do mapping of host names to IPs. Okay, and when you, then the computer will look at this first to see if it already knows, because really all it needs to know is I have this host name on the browser, what's the IP address for it, correct? And so it's going to look in here, and you guys will see when we start up the VM that etc host does have mappings in there. You can add other mappings, and in fact, one of the problems in your lab will relate to just this file alone. Right. So in Unix, you can list translations in this file etc host. If that doesn't work, so this would be like step one, then step number two will be to contact the assigned DNS server. So contact the DNS server and ask it to perform this. And then if the DNS server does not know it, then the DNS server can query its own DNS servers and basically try to obtain it that way, right? So that's really the idea. There's always, it's a hierarchical tree structure where DNS servers can query someone who's expected to tell you something. Well, this might give you the resolution. So remember that this is important, right? So think of this idea. In a zone, you have, you can have WW, mail, DNS, you know, you have, and you can have and then also not just one WW, right? You can have multiple web servers, multiple mail servers, etc. So this DNS server contains all that information for that company. But the DNS server that this DNS server will contact will have information just to say, okay, if you need resolution about this domain, go to this DNS server, and then that DNS server can give you the specific answer that you're looking for. Do you guys see what I'm saying? So that's basically the idea. It's almost like, okay, I need to know a specific web server for electricity.com, right? So I don't know it. I go to someone, that DNS server that tells me, okay, go to this DNS server. They know it, right? And that's basically the idea. Yeah. This one, etc host, is just a text file, and it's not big actually. It's meant to be pretty small. It just has a few things in there that are very specific to you, so that this is the first place that you look at, and then you don't have to go to your own DNS server. And what if you don't know? Then you go to the internet. We will do something like that. Flushing the cache, you mean? So in the DNS server, so if we flushed the DNS of this, we would flush the etc host, right? For the local machine. But now, probably where you've heard that term, flushing the DNS cache, relates to the actual DNS server, because the DNS server, think of it. You think of this, right? So we have here, here, and here. So you want to know how to get to here, but you contact your DNS server, it doesn't know, so it has to contact someone else to tell it how to get to this other place. Once it does it, it's going to cache it. it's going to cache that information. Why does it cache it? So the next time that the client wants to get there, it's going to query you and you know it. So you don't have to send more packets out into the internet. So understand that when you get a response from your DNS server, that response does not go in here. Okay, maybe that's what you were thinking. It does not go in there. It's not that type of a file. This is more of a permanent file that is not modified. Okay. So usually the way it works is you always want to rely on your DNS servers, basically. Okay, but in Linux, you do have, for some specific IP address, etc., this file that you can put things in. And it's just basically, it'll say like whatever. I mean, could be local to your machine, because you could always redirect a local host and a specific port number, for instance. Right? So it's just those kinds of mappings. It's very flexible and powerful. Got it? Any other questions, guys? All right. So so then let's take a look here. So we're looking at the etc host file. Okay, and so in here you're going to have, for instance, things that you usually see in there is the redirect IP, the loopback, right? So the loopback address and maps to localhost. Localhost is the host name for your own machine, right? Usually, so you can reference yourself. But then you might have other IPs, 192.168.1.3, and that's just some server. Let's say it's called Canada. I don't know. Right. So whatever it is, it's just some server that you want to get to, and then you have the host mapping there. Okay. So to configure now, remember that for configuring bind or configuring DNS, let's say, you're going to have to configure the client and also the server. Okay, zones relate to the server, but on the client, you do have to configure something beyond the etc host file. Okay, so the etc host file does not actually allow you or relate really to the DNS server itself. Instead, it is just its own little DNS thing. Now, if you want to configure the client to use this DNS server over here, so on the client side, then DNS configuration should be very simple, and it would center around the file called etc resolve.configuration. Okay, so it would relate to that file. Okay. So for instance, when do I do this? On my computer, on Mac, actually, I'll show you guys something, but this thing here is specific to Linux, and it's basically, you've probably seen this file. This is the file where you download automatically when you connect to a network, any network. Let's say you connect to PNW, it automatically downloads name servers, right? That's basically the mechanism. And then you're kind of governed by those name servers to be able to do all kind of resolutions, right? So usually browsers want to download Google's servers because Google's servers, actually, I don't know if you're aware of this, but they're structured in such a way that they go through their entire ad space, their whole ad delivery system, right? So actually DNS is tied deeply with the ad delivery system. Did you guys know that? Yeah. So it's not just this is 1984, but what they've done is very convoluted now, and the way that we do things going to let's say Google or the default, all the default IPs that we get, all the DNSs that we get, they basically take us to this ad domain system. But basically, the idea is that on the client side, the configuration revolves around this file. This file basically lists the local domain name and the locations of the name servers, right, to be used by the local systems. And this is usually downloaded automatically. So if we think about this as the file resolve.configuration, then you would have the entries in there would be name server, and then, you know, some IP addresses that are downloaded. So like I said, all of this you can look up on your VM, but that's the basic idea. So if we're dealing with just plain Linux, right, obviously it's a text file, etc conf. When you connect to the network, these get downloaded automatically. There is an additional file, the resolve head file. If you go to that file, then that file can be configured so that you always automatically download a specific set of name servers that you've designated as your name servers, so that even if you connect to a new network, this will not work, that it tries to download the name servers from that network. Instead, you're always going to be using your own predefined ones. Do you see what I'm saying? Does that make sense? All right, so that's the idea there. So what's one scenario where you would want to do that? One scenario is you want to avoid as much as possible as I said, the ad space framework of Google, right? Which is a very difficult, or Facebook, or all of it, which is very difficult to do. So one of the only ways that you might be able to do that is by having another set of name servers, of DNS servers. These DNS servers need to be created by someone who is specifically trying to do that. You see that they're specifically trying, they know how to, you know, they'll have the IPs that you need, but they're going to try to not send you through the channels that Google has where they serve you their ad network. All right, so one example of this is alternate DNS. Have any of you heard of the alternate DNS? No? Okay, so let's take a look at that. So I've used alternate DNS sometimes, and I like it. Here it is, alternate DNS. So it's an ad blocking DNS server. So it's basically, that's, as you can see, as I've been saying, whenever you download a website, right? We go to a host name, we need to get the IP mapping, but we are sent to DNS servers that will deliver ads. However, we have the option of using something like what they provide, alternate DNS, which offers an affordable global domain name system resolution service that you can use to block unwanted ads. Okay. Basically, what you have to do is they give you 2 DNS servers, and you just have to set these as your fixed DNS servers instead of getting automatic DNS servers, like I said. You guys understand? Yeah. So this is an alternative. And so what happens here is when it does the resolution, where your website would have shown all these ads, now it just shows blank, or it doesn't show things. You know, and so that's kind of an interesting solution. How they do it, I assume they filter certain IPs, so that there's got to be a route that they follow that, you know, because really, like every little piece, right? Every little piece that comes into your website is coming from somewhere different. So you have a website. Well, actually, let's use this. You have this website, and that's the main website, but then every little one of these is coming from a different IP, which is the ad serving network, which is using your privacy, you know, or the lack thereof, right? So what they, you know, the profile that they've created to deliver an ad specifically to you. But by blocking some of these, like ad block and all that, and there's many, then you get the website with blanks and so on. Yeah, you have a question. DNS is DNS is still for resolution. That's all it does. The tracking is done differently. It used to be done through cookies, but now it's done completely different. They're just collecting everything of you. And remember, it used to be, for instance, in our homes, the outside IP of our home was always randomly being changed. That was kind of the more optimal solution. Nowadays, a lot of our external IPs are fixed. So you're kind of locked in. And so the problem with that is everything you've ever done, like every search you've ever done in your home for the last 3-4 years has been tied to that external IP. And that data is in Google. So every time they see that IP, what's your name? Andrew. So every time they see that external IP, Andrew. And then they have some other information like Mac or something, and that's your computer, Andrew. You know what I mean? So it's not even the cookie anymore. It's just they're collecting so much, and your profile is now on the internet. It's no longer like you can just clear the cache and you're done, right? Your history. That was a long time ago. And so, yeah, so all that information they have. And so that's why it works like this. So you download the main page, which is really what you want, right? But it's news, some news site. But then it's got all of these, and all of these need to go to the different IPs. And then there's a little piece of information of who you were, right? And then they're going to deliver the content specific to you. So those are two. So the way that they track you in the DNS resolution, they're two different things. But once they know who you are, they're going to redirect you to an IP that they think of ads that you would like. And that's where the DNS comes in, tries to do that resolution. You see that? But if it's blocked by something like alternate DNS, then it won't deliver the content. And it'll just get a blank or missing or something like that. You see that? What is it? DuckDuckGo also tries to do a little bit of that by not letting them track you, and also a little bit with the ads as well, which is kind of the same principle of just blocking certain IPs. If you try to create your own DNS, right, at home to block, or your own list of blocking websites of ads, it'd be impossible because they're constantly changing it. So even if you had a good, robust list, it'll become, it won't work. And so that's why you kind of need something like this, where they're dedicated to this. Now, what I've noticed, though, is that what they've intentionally done is they've slowed down the response. So the name resolution, the name resolution when you go through something like alternate DNS is a bit slower, because I don't know, it could be that they just don't have enough infrastructure, or I think it's more likely that it's something like the Googles and the Facebooks that they just don't reply. They know who's making the query or whatever, and they just don't send, because I've noticed it's slower for me. Sometimes it's actually frustrating how slow it is. But it's certainly, they're always in flux, right? And it's always changing to see what they can do. But anyway, that's kind of something I wanted to talk about. Well, I have a free one. Yeah, I have a free one. Yeah, but the problem, your ad blocker with Pi, as I said, you have to keep that up to date. That's the problem. With something that alternate DNS, at least they're doing this constantly. It might be that mine is slower because I don't pay. I mean, that's also certainly a possibility. But you can try it out if you're interested. I mean, it's pretty easy. You just add these DNS. If you were doing it straight up in Linux, as I said, if we go back to the whiteboard, you would just, as I said, in the etc resolve.configuration file, you would want to, there's an additional file, an additional command that basically says every time, and I think it's called the resolve head. So every time you load the machine, load static name servers in here instead of the dynamically obtained name servers. Got it? All right. Okay, so let's see. So let's see if I have a few more commands to give you. And then on Thursday, we'll go over the VM. So commands for DNS. So Linux, let's say Linux DNS commands. So we're going to have, so this is just a terminal. So there should be one, who is, and then let's say purdue.edu. So that's a command to try. Now, another thing to consider is that DNS listens on port 53, right? And apparently it's got 53 UDP and TCP. Okay. If you want to know, let's say, determine if bind is running, this is something that you should be able to do now. You can do PS, AX, pipe it into grep, and then just say name. Right, so this will give you the list of all the processes that are running, and then you just pipe it into grep and look for the word name. Okay, so if you want to install bind, to install, you can do sudo apt and then install bind9. Bind9. Another command is the dig command. So if you want to query DNS, a DNS server, for instance, then you can do something like dig. So dig, for instance, pnw.edu, and it's just going to give you information about that domain. Now let's look at one. Let's look at, if you want to just, I'm out of slides here. Let me just erase. Okay, let's say that you just want to get the addresses of the root servers, of root DNS servers. So get address of root DNS servers, so the ones that respond to things. You can just do the dig command. Now, let's say that you want to do a reverse lookup. So you want to do a reverse lookup. Then you would do dig -x and then the IP address. So when would you use this? Let's say, for instance, that you're getting a lot of spam, right, from that IP address 58.9.62.229. So you want to know who that address belongs to. So that's a reverse lookup, right? So then you can do something like this. Okay. Now, the tool that you're going to use for the attacks is called NetWatch. So let me erase. Oh, I can do that. So the tool that we're going to use for the attacks is called netwalks. There's also a tool called netwag. And netwag is just the GUI interface of netwalk. So you'll probably end up using netwag because it's and we'll review this later. You'll need to do sudo because you need to get a network card, right? So that you can send out packets. So you'll do netwag. Okay, and this will open up a little screen, a little screen, a GUI with buttons, etc., where you can enter specific commands. Okay. All right, and I think that's it as far as the theory for today. Hopefully that's a good enough introduction to DNS. And then on Thursday, we will focus just on the lab. So we'll start with the VM and go over how to get started with the lab and some additional working on the machine. All right, so that's it. So I'm going to stop the recording.